Okay, we're going to be putting a bunch of our stoichiometry conversion factors together in order to solve a relatively complicated question. How many grams of aluminum oxide? That's what we're trying to get to. That's what our answer should be in terms of. Are produced from 1.205 times 10 to the 24th atoms of aluminum. That's going to be our starting point for our dimensional analysis. So, here's sort of a map of what we're trying to go from. We're trying to start with atoms of aluminum, and we want to end up with grams of aluminum oxide. It would be fantastic if there was a one-step conversion factor to get us from one to the other, but there's not. We're going to have to make many stops along the way. The first thing that you should really note is that we are starting with aluminum and we are ending with aluminum oxide. Whenever you go from one kind of a compound to another, you must go through the moles. So here's sort of what our map is going to look like. First thing we're going to do is we're going to transfer atoms of aluminum into moles of aluminum. The conversion factor that we're going to use in order to get from atoms to moles is Avogadro's number. Then we're going to take another step to go from moles of aluminum to moles of aluminum oxide. And in order to get from moles of aluminum to moles of aluminum oxide, we are going to use the balanced chemical equation. Those coefficients tell us the molar ratio of the different reactants and products to each other. And then finally, moles of aluminum oxide to grams of aluminum oxide is going to be from the molecular weight of aluminum oxide. All right, so let's get started. We're going to start with our 1.205 times 10 to the 24th atoms of aluminum. For every 6.02 times 10 to the 23rd atoms of aluminum, there is 1 mole of aluminum. That's Avogadro's number. Next up, the balanced chemical equation tells us 4 moles of aluminum are required to make 2 moles of aluminum oxide. That comes from the coefficients of the balanced chemical equation. 4 aluminums to form 2 aluminum oxides. And then just one more step, we need the molecular weight of aluminum oxide. So, we have 2 aluminums. That gives us 2 times 26.98 plus 3 oxygens, 3 times 16. Add those together, so we get 2 times 26.98 plus 3 times 16 gives us a molecular weight of aluminum oxide of 101.96 grams per mole. That means there's 101.96 grams of aluminum oxide in 1 mole of aluminum oxide. So that's our last step in the conversion process. 1 mole of aluminum oxide goes on the bottom, and 101.96 grams of aluminum oxide goes on the top. Double check, make sure everything cancels. Atoms with atoms, moles of aluminum with moles of aluminum, moles of aluminum oxide with moles of aluminum oxide. So we get 1.205 times 10 to the 24th times 2 times 101.96 divided by 6.02 times 10 to the 23rd gives us a grand total of 408.2 grams of aluminum oxide. So if we start with 1.205 times 10 to the 24th atoms, we will end with 408.2 grams of aluminum oxide.